Hi guys, it's me, and I am here to demonstrate how to do a repeated measures ANOVA using SPSS. So I'm referencing the data set on page 434 of your textbook. It's a demonstration of a research study where they were looking at how sleep deprivation affected motor skills performance, and there were 3 separate conditions. It was a within subject design, so each participant first did the motor skills task after 24 hours of sleep deprivation. Then they were tested again after 36 hours, and then they were tested again after 48 hours. So I'm going to be entering the data from page 434. The first thing I want to do is create my variables, so I'm in variable view. Here in the name column, it doesn't allow you to type numbers, so we're going to have to spell it out. So 24 hours, and we're going to leave that numeric. We're going to go here to the label. Here I can use numbers, so I'm going to say 24 hours of sleep deprivation. And then it's going to be scale data. I'm going to do the same thing for the 36 and 48 hours. Again, scale data, and now I'm going to do the same thing for 48 hours. Sorry, I have kids in the room with me. Okay, so now I'm going to go over to the data view, and I'm going to enter in our data, and page 434 tells me that after 24 hours, participant A had 0 motor errors, B had 1, C had 0, D had 4, and then the last one had 0. After 36 hours, still 0, 3, 1, 5, and 1. And then at 48 hours, it's 6, 5, 5, 9, and 5. And so that's all of our data, and we have our variables. So now we're going to go to Analyze. We're going to go to the General Linear Model, which is nothing we have used before, but it's based on equations. It's based on equations surrounding proving the linearity, equations corresponding to lines. And so we're assuming this is a linear model with our data set. And again, that's based on the assumptions we've talked about in class, including assumptions of normality, homoscedasticity, and independent observations. Okay, so Analyze, General Linear Model, and Repeated Measures. And so we're just going to change the name of our factor to Amount of Sleep Deprivation. And then we have 3 levels, so we're going to add that in. Oh, it's not liking me putting spaces in there, so I'm going to now add it in. And I'm going to hit Define, and now it's actually set up where I need to define each of the 3 levels. So for level 1, it's going to be the 24 hours, so I'm just going to throw that over there. 36, throw that over for number 2, and 48 is going to throw that into number 3. And now it's filled in the titles that we gave it for each of the respective levels of our factor. Additionally, while I'm in here, I'm going to go through and I'm going to get my descriptive stats. So I want overall means, and those are the grand means that we talked about when we went over the formulas. Remember, the grand means, I'm looking at not just the means of 24 hours, but the means of the entire study. And then I'm also going to throw in the amount of sleep deprivation so I can see each of the individual means for each of the groups. I'm also going to click on descriptive stats, effect size, because that's always going to be important. And while we're here, we might as well already check the homogeneity. And then comparing main effects is going to be relevant to the two-way ANOVA that we'll talk about later. And again, it defaults to confidence intervals of 95%, which is fine. So I'm going to hit continue and then OK. And here's my output. So my output shows me that I have a mean of 1 error for 24 hours. The level of errors that they were making increased as they were experiencing greater amounts of sleep deprivation. Every level and condition had 5 participants for a total of 15 scores. So these would all be the little n's, and then the big N would be 15. And then I'm also, where I need to focus interpreting the output is right here, because this is a within subject effect. And so I want to look at, did we have a significant repeated ANOVA? So I need the between subjects degrees of freedom, which is K minus 1. And then I divide that by my within subject degrees of freedom. And so it's going to be F equals parenthesis 2 comma 8 close parenthesis 70.0. And since my significance, and mind you, here's different versions that have been run, we're going to adhere to the sphericity assumed right now, because we're assuming that our sample is meets the assumption of homogeneity. And then it is significant. And it really doesn't matter, because if you look at all of these, they're significant. And this partial eta squared actually represents our effect size. Remember that funny looking n is eta in Greek, and so that is going to be our effect size variable. And so I am going to put this on Blackboard in a PDF format, and I'll kind of highlight the important numbers, and I will type out a sample results section so you can see how you actually need to present these findings for repeated measures ANOVA. But I do want you to use this as a reference point, and also please compare this to the output that you see on page, well, they actually don't do the output. They do the manual calculations, and that's demonstration 13.1 on page 434 and 435. So you can compare our SPSS analysis to the hand computations that are outlined in the book, and clearly doing it through SPSS is far more advantageous and less stressful for all parties involved. Okay, then if you have any questions, I'll look forward to addressing those in class.